Okay, hopefully this is recording. So this is a quick overview of OAuth 2.0. OAuth 1.0 is dead or deprecated. So usually when you hear this, it's OAuth 2.0. Just when you hear OAuth, it's OAuth 2. Cool. So let's go. So put simply, OAuth is an open standard, which means no one owns it, where user of a service A can allow a third-party application B to access that data hosted within service A without revealing their login credentials to service B. So in this case, service A can be Google for sort of ease of imagining that. So service A is Google, service B is any other service that you've ever used. So it could be a charity that you can import your contacts from Google from. It can be a photo printing site that allows you to print your photos within Google Photos. So the idea is that you never have to give application B your Google username and password, but still you can access your data within Google. Or this third-party app rather can access your data that sits within Google. That's essentially what is. So technically speaking, OAuth is an open standard for authorization. Remember that word, authorization, that apps can use for secure delegated access. So let's just take this bit. So it's an open standard for authorization. So this was the biggest revelation when I looked into this, because in my head, like the words authorization and authentication kind of mean the same thing. But the big aside, or the big concept to understand is they're completely not the same thing. So authentication is the process of verifying who a user is. Authorization is the process of verifying what they have access to. I think the best example is, imagine yourself at an airport going on holiday. So you have your passport and you have your boarding pass. So your passport is what authenticates you, or is what verifies you as the person you say you are. And authorization is your boarding pass, which verifies what you have access to. So you don't have access to that flight going to America. You do have access to that flight going to Spain, and that's the kind of main difference between the two. And technically speaking, authentication is beyond the OAuth spec, but we still can use OAuth for authentication with something else added on, and I'll come to that in a bit. So for now, just forget that you can use authentication. You can authenticate using the OAuth spec. Cool. So I'm sure you've seen screens like this and like this and like this before. And in this particular example, this user is giving this web app or the third-party app access to their Twitter data, and this is the data they're giving access to. So this application will be able to do all of these things and not be able to do all of these things. And within the OAuth domain, we call this scope, and I'm sure you've seen this if you've ever used Auth0 has scopes. You'll be familiar with that. Cool. So again, quick example of delegated one-time access. So cancercharity.com is a website you are passionate about. You want an easy way to share your address book with this third party. You can use OAuth in this example to share your Google contacts with this cancer charity. Okay, let's cover the OAuth flow. So we have an explicit flow and implicit flow. And where it says front and back channel and front channel only, just think of this as front end and back end, and front end only. So with the explicit flow, we have both the front end and the back end involved. With the implicit flow, it's only front end. The implicit flow is not recommended because it's not secure in any way or form, really. And I think OAuth have come out and said you should not be using the implicit flow. Okay, so quickly looking at the explicit flow, I'm just going to go over to draw.io. Cool. This is our explicit flow here. So before any of this happens, so this is a user, this is a web app. Before any of this happens, as you can imagine, when you're building the app and you want to integrate it with Google, you would go to Google and sign up for a developer account, get a client ID and a secret. Just a client ID is just to identify you, and a secret is something that only you have. So you can present that to Google and say, "This I am who I say I am." Cool. So we have a client ID and secret before we begin any of this. And when the user clicks on continue with Google, remember they're not logging in. They're just trying to access or give us access, give this client web app access to some of the data they have within this service. Cool. So they click on this, and this is the link we go to. So these are just some query params. So we have the client ID, which we don't really care about making public. So it's like, cool, this is my client ID. This is the redirect URI. This is essentially because we're sending them outside of our domain. We're sending to another website. We're saying, hey, once you're done here, this is where Google, this is where I want you to come back to. And oh yeah, this is in this example, I've just taken this Oauth party as Google. So this is our authorization server here. So yeah, we're just saying, hey Google, when you're done, send them back to this URL. Scope is what I covered previously. So the scope is the things you are asking for. So you maybe want to. I don't understand. Oh my God. Maybe you don't want you want to access someone's photos, but you don't want to have the rights to edit them. You want to read someone's contacts, but you don't want to be able to delete them. So that's essentially what scope is. Response type, you're basically telling Google, hey, I'm looking for an authorization code. And you're sending some state, which is just a long string or a short string. But I'll come to why state is important in a bit. So this is what you send over. The user sees their normal login screen. They log in successfully, and they see that screen that I had before, which is, hey, these are all the things you're giving this app access to. Are you happy with this? User clicks yes. Google will then use our callback URI that we provided up here, the redirect URI, and send it back here, and then give us our code inside query params along with the state. So it just gives our state back to us to say, hey, this was in the request. I'm sending this back just to prove that this is coming back from Google, just so you know. I'll cover that in a bit more, like I said. So that comes back into our domain. So these sort of boxes are the front end, and anything that is a 3D box is the back end, just for ease. So we come back to our callback URL. We now have an authorization code, or a code that came back from Google, which we post to our back end. This is where the front channel and the back channel comes into play. So this is the explicit flow, where the back channel is involved as well, and you'll see why. So we now the backend server of our web app has the authorization code. We now use that, and our payload looks like this. So we send our code, or our authorization code, our client ID, which, like I said, we don't really care about it being public. Our client secret, which is as the name implies, secret, and a grant type. So we are asking for the authorization code, or the access code. Or I guess we're giving them the authorization code, is what that means. So we give them this payload, and if everything's good, the authorization server, again, backend server, sends back an access token that we can then use to access the data. So in this example, because it's Google, and usually it works like this, so your authorization endpoints will be different from your resource server endpoints. And by resource server, I just mean the server that the API that basically holds the data you're looking for. So it can be Google Photos, Google Docs, your Google Contacts, Google profile information, all of that stuff. Cool. So this is what your payload looks like going back to the resource server. So you're saying in your headers, you have a bearer token, which basically implies that once you have a bearer token, you can just access all of the resources that you have the right to access. Oh, and I should mention that this access token, which comes from Google, is signed with things that you can access using it. So you can't use an access token now to access things that you shouldn't be accessing, that the user didn't agree to, essentially. Cool. So if everything's good, we get our payload back. So let's say these are just this is just profile information for that user. So we get that back up into our backend, which we then send back up as the response. And then we can change this loading screen up and load this profile information that we just got. That is essentially the entire flow for this. And yeah, this is kind of the most secure way of doing it, because this is the back channel communication that's happening, and ideally, really, it's no one can. This is a secure channel because no one can really intercept these messages because it's happening back into back end, versus in the front end, which we will see in the implicit OAuth flow, which involves the front channel only. So again, like you can see, no back channel involved at all, apart from when we go to the Google resource server. So here, the only thing that changes is the response type. Here, instead of code, you're asking for a token. Our Google authorization server authenticates the user allows access, and then we get the token back, which we then set as our bearer token to access whatever we want, which again, as you can see, much simpler, don't need a backend. Also not very secure because someone could be like sitting right here outside your house, sucking up everything that's coming through your Wi-Fi onto your laptop, and then just intercept your token. Once someone has your token, that's essentially game over, because they now can pretend to be you and steal all of your data. So obviously not great and not recommended, but that's what that is. Cool. So we just finished the implicit flow. So like I said, back-channel communication is more secure. It avoids packet sniffing, man-in-the-middle attacks, malicious browser extensions, etc., from intercepting your signal and stealing all of your data. So access tokens are users' bearer tokens, already mentioned. And the bearer can access any resource that they're authorized to without any further identification. Access tokens have a shorter lifespan, and once they expire, the user must authorize again. Whereas refresh tokens, which is a new concept, I didn't really cover that. So usually you get the refresh token along with the access token, and essentially the idea of a refresh token is to strike a balance between user experience and security. Because you don't want the user to be logging themselves in every 10 minutes or every time they want to use your app. So the idea is they send back a refresh token. So after your access token expires, we can use a refresh token to refresh our access token or to get a new access token, and then continue to use the app, and the user doesn't even notice and doesn't have to sign in every 5 minutes, 2 minutes, whatever. So refresh tokens have a longer lifespan. If something does happen, though, if the user does cancel the account with us, we can revoke once the user has told Google, hey, don't share my data with this web app anymore, Google can then revoke that refresh token. So the next time that app goes to Google to say, hey, can I have an access token, Google can deny that at that point and sort of make your data secure again and not share it. Cool. So coming back to authentication, so I mentioned that OAuth does not support authentication in its specifications. So this is where OpenID Connect comes in, and I'd never heard of this. So essentially, OAuth 2.0 along with OpenID Connect makes authentication possible. And here's sort of the story of it. So obviously you've seen these pages. You probably used one today um, to sort of using log in with Google, log in with GitHub, log in with Facebook, etc. So um, there's no standard way of getting a user's information, and a bunch of these companies came up with their own internal implementations, which were all different and not standard. To solve this problem, OpenID Connect was essentially, it came out of this need to have some sort of a standard, and that's what that is. So what does OpenID add to OAuth? So OpenID is just another layer on top of OAuth, if you can imagine it that way. It's not really a standalone protocol. It's something that works with OAuth to make authentication possible. So it adds standardization, interoperability, um, an ID token which we get where we can store user information. So if you've ever sort of gotten a jot back from like Oauth2, for example, and then unpack that jot to find some user information in that, that's basically an OpenID ID token. And also services that implement OpenID will give you a user info endpoint to get more user information if you need even more information, that is. And a standard set of scopes. So OpenID standard realizes that most web apps need certain scopes or use these patterns over and over. So it's just kind of baked it into the standard. These scopes look like this. So going from bottom to top. So email is obviously the user's email, but also flags like an email verified Boolean. Because that, again, that's patterns repeated over and over. A profile which contains their name, middle name, nickname, all of that stuff. And finally, a sub claim within the OpenID scope, which uniquely identifies the user. Yeah, just repeating myself again. So the ID token is the biggest thing that OpenID adds to OAuth 2.0. So here's what the OpenID Connect flow looks like. You scroll here. Here we go. So here, the only difference is when we request scopes, we are just requesting an OpenID scope as well. And the flow remains the same as the explicit flow. The only difference is when we ask for an access token, we also get an ID token back, which is the jot. And we can now, there's another player here now, which is the user info endpoint. And we can query this endpoint if we want to know more about that user. Everything else remains exactly the same. This is what we just covered. So the ID token is a JOT or a JSON web token. Encoded in the payload are claims that include information about the user, like email, and additional user information can be obtained by the user info endpoint, which is again standardized. And it requires a valid access token to get that information. Cool, moving on. So it's just a few things that kind of stood out to me, so I've included it in here. So the OpenID spec recommends an SSL or a TLS while sending auth tokens in plain text over the network. So it doesn't actually implement it, or it doesn't require you to implement it. It recommends it. I just thought that was interesting. Authorization codes should be one-time use only for maximum security within the OAuth spec. I also thought that was interesting. Access tokens are a single point of failure, because if someone else gets your access token, they essentially now have access to everything that you have access to. So they can potentially steal all your data, which is important to note over and over. So this is why it's important to for you to make sure that your app is secure and not logging someone's access token, for example, because that can be stolen very easily. And yeah, the state parameter that we send to the authorization server um, serves to protect against cross-site request forgery, or CSRF. Essentially, what this means is with, without this, an attacker could potentially just sit in the middle and return fake data from an API. And this basically just prevents that. Um, I'm not entirely clear on if this is valid even for the explicit flow, but yeah, it's something I'm going to look into a bit more. And I think that is the end. That's right. Okay, cool. We'll stop this now.